Welcome to the second Public Information Center, or PIC, for the Schedule C Municipal Class Environmental Assessment for the Dixie-Dundas Flood Mitigation Project. Matrix Solutions is leading this project with expertise in hydraulics, geomorphology of the creek, and environmental and ecological background. Matrix is completing this project in partnership with Cambium Indigenous Professional Services, our team for First Nations consultation, FOREC, our landscape design team, and RV Anderson Associates Limited, the main expertise behind bridge crossings, transportation, and other linear infrastructure in the area. We acknowledge the lands which constitute the present-day City of Mississauga as being part of the treaty and traditional territory of the Mississaugas of the Credit First Nation, the Haudenosaunee Confederacy, and the Huron-Wendat and Wyandot nations. We recognize these peoples and their ancestors as peoples who inhabited these lands since time immemorial. The City of Mississauga is home to many global Indigenous peoples. As a municipality, the City of Mississauga is actively working toward reconciliation by confronting our past and our present, providing space for Indigenous peoples within their territory, to recognize and uphold their treaty rights, and to support Indigenous peoples. We formally recognize the Anishinaabe origins of our name and continue to make Mississauga a safe space for all Indigenous peoples. There are two project managers for this project: Anthony DiGiandomenico, the project manager for the City of Mississauga, and Amanda McKay, the consultant project manager for Matrix. If you would like to be included on the project mailing list and provide your input, please fill out a project comment form, which is available on the city's website at www.mississauga.ca/flooding. The PIC No. 2 presentation agenda includes the following items: a brief project overview, a recap of the preferred alternative solution that was selected from the alternative solutions presented in PIC No. 1, a review of the considerations when developing the various alternative design concepts, an explanation of the alternative design concepts that were selected for Phase 3 of the environmental assessment evaluation, a review of the preliminary evaluation of the alternative design concepts, and an overview of the overall preliminary preferred design solution and the next steps in the environmental assessment process. Let's start with the project overview. The City of Mississauga, through the Dixie-Dundas Flood Mitigation Feasibility Study and the Municipal Class Environmental Assessment process, is seeking solutions to address flooding from Little Etobicoke Creek, to protect existing residences and businesses, and to enable future growth of the city. There are approximately 1,000 residential, commercial, and industrial properties between the Little Etobicoke Creek study area and the QEW that are at a risk of flooding. The City of Mississauga has an interest in intensifying the Dixie-Dundas corridor to fulfill the vision of growth expressed in the Dundas Connects Master Plan. The image on the right shows flooding at the Dundas Street East and Queen Frederica Drive intersection that occurred during the July 2013 storm. During a regulatory event, the extent of flooding associated with a spill from Little Etobicoke Creek is shown on the map to the right near Queen Frederica Drive. The flooding extent shown on the map was determined and detailed through regional flood mapping, which is dictated by the Ministry of Natural Resources and Forestry and regulated by the Toronto and Region Conservation Authority. The analysis indicates about 1,000 residential, commercial, and industrial properties are at a significant flood risk during the regulatory storm. As well, this flood risk was only mapped as far as the QEW. Flooding is anticipated to continue beyond the QEW, further south, to make its way out to Lake Ontario. The objectives of the Dixie-Dundas Environmental Assessment Project can be summarized in a statement. Residents and businesses in the Dixie-Dundas community are currently highly vulnerable to flooding from Little Etobicoke Creek. The Dixie-Dundas Flood Mitigation Feasibility Study and Class Environmental Assessment will assess solutions to provide flood protection to residents and businesses, as well as enable future growth. It is our hope that the environmental assessment achieves the following objectives: address riverine urban flooding issues, protect and enhance a natural environment, build resilient and adaptable solutions, plan and design feasible infrastructure solutions, and enable growth and development. Two-dimensional modeling to define the very complex flooding that occurs in the Dixie and Dundas areas began as early as 2012 and was completed around 2015. In July 2013, a significant flooding event did occur in the Dixie and Dundas areas, highlighting the need for further understanding of the potential flood extent. An expansion of the initial two-dimensional modeling to define flooding from the Dixie and Dundas areas down to the QEW was completed as part of the Little Etobicoke Creek Flood Evaluation Study and Master Plan in 2018. This led to the current project, the Class Environmental Assessment, which began in April 2019. Matrix completed the feasibility portion of the project between April 2019 and July 2020, and the first PIC was held online in August 2020. As the project evolved, there was a need to expand the study area. That brings us to where we are today, which is PIC number 2. Following this PIC, Matrix plans to complete the environmental study report in July and August of 2023. Once complete, the environmental study report will be posted for the public to review for 30 days. The project will then move on to preliminary design through the fall of 2023, finishing up before the end of the year. It is anticipated that detailed design and any required land acquisition will be completed between 2024 and 2026. There are many components of construction that are set to begin in 2026 that are estimated for completion by 2035. This slide outlines the municipal class environmental assessment process, specifically the 5 phases that are associated in the process. Currently, the Dixie-Dundas Environmental Assessment Project is in Phase 3 of the Schedule C Municipal Class Environmental Assessment process. The project team has developed alternative design concepts for the preferred alternative solutions selected during Phase 2, and has decided on a preliminary preferred design solution based on the evaluation criteria. The main intent of this PIC is to explain the alternative design concepts and the preliminary preferred design solution in order to gain feedback. Following this PIC, the project team will complete an environmental study report that will summarize the entire process and the inputs into the process, which is Phase 4. The preliminary design, as outlined earlier, is anticipated to begin in the fall of 2023, which is Phase 5. There have been 2 points of public feedback leading up to this PIC. PIC number 1 was presented in August 2020 and introduced the project and the identified problem, described the environmental context, presented alternative solutions to address the problem, outlined the evaluation criteria, and provided opportunity for interested parties to offer input. A project bulletin was released in October of 2021. The bulletin outlined the need to expand the study area for the environmental assessment, as the solution to mitigate the flows in the Dundas area could have the potential to cause flooding further downstream. The project bulletin described the environmental context of the new expanded study area, presented alternative solutions to address the secondary problem, outlined evaluation criteria, and provided opportunity for interested parties to offer input. Now, at PIC number 2, we will present the alternative design concepts, how they were evaluated, the preliminary preferred design solutions, and provide opportunity for interested parties to offer input. We will now review the alternative design solutions and how they were evaluated for the Dixie and Dundas areas. Here is a recap of the alternative solutions that were presented in PIC number 1 and the project bulletin. For the Dixie area, each alternative solution represents a different approach to maintain flow within the Little Etobicoke Creek Valley Corridor, combined with the replacement of the Dixie Road Bridge. Alternative Solution 1, Improved Conveyance with a Minimized Footprint, includes a concept that creates a narrow and deep channel through the Dixie area. The channel top width would be increased, however the upstream 600 meters of channel would be lowered by 1 meter on average. The Dixie Road Bridge would be replaced with a single-span 26-meter bridge. Alternative Solution 2, Improved Conveyance by Making Room for the Creek, is modeled on natural channel design concepts, with a widened channel and lowered adjacent ground to create a much wider and better connected floodplain. The channel top width would increase, and the channel depth would be lowered along with the surrounding areas to better connect the floodplain. The concept of Alternative Solution 3, Flood Containment with Mitigation for Upstream Impacts, is to contain the regional event within the Valley Corridor using a flood protection landform, known as an FPL. The FPL would extend from approximately 500 meters upstream of Dixie Road to 700 meters downstream of Dixie Road. This option would require quite a wide footprint area due to the shallow slope on the dry side of the FPL. Alternative Solution 4 is to do nothing. For the Dundas area, each alternative solution represents a replacement of the existing Dundas Street Bridge to keep flow within the Little Etobicoke Creek Valley corridor. Alternative Solution 1 would be to replace the Dundas Street Bridge with a 25-meter single-span bridge with downstream floodplain conveyance improvements. Alternative Solution 2 would be to replace the Dundas Street Bridge with a 38-meter double-span bridge without downstream floodplain conveyance improvements. Alternative Solution 3 would replace the Dundas Street Bridge with a 38-meter double-span bridge with downstream floodplain conveyance improvements. And Alternative Solution 4 is to do nothing. Each alternative solution, including the do-nothing approach, was evaluated based on the following criteria. Technical criteria, which include flood risk improvement, urban drainage impacts such as storm sewers and outfalls, increased erosion potential, construction approaches, and climate change resiliency. Economic criteria, which include capital costs, operation and maintenance costs, urban development, and municipal servicing considerations. Environment criteria, which include aquatic ecology, terrestrial ecology, and geomorphology. And social criteria, which include policy and planning considerations, public input, property impacts, public disruption, parks and recreational amenities, cultural heritage, and archaeological and First Nations input. Consultation is an essential part of the municipal class environmental assessment process. The City of Mississauga wants to ensure that anyone with an interest in the study has the opportunity to provide input as the study proceeds. There have been over 200 views of the PIC No. 1 presentation and the project bulletin that were previously posted online. In general, the comments received to date from the public have expressed support for the flood mitigation solutions presented for the Dixie-Dundas area. Toronto and Region Conservation Authority and the Regional Municipality of Peel have participated in ongoing project collaboration and provided input into the project. Cambium Indigenous Professional Services, one of our partners on this project, continues to lead the project engagement with Indigenous communities. The project team continues to have ongoing consultation with Indigenous landowners, as well as ongoing coordination with other City of Mississauga initiatives, including the Bus Rapid Transit Project. This chart outlines the results of the Alternative Solutions evaluation for the Dixie area. For technical criteria, Alternative Solutions 1, 2, and 3 would remove the spill at Queen Frederica Drive. Alternative Solution 4 would not. Alternative Solutions 1 and 2 would decrease upstream water levels, whereas Alternative Solutions 3 and 4 would not change upstream water levels. Conversely, Alternative Solutions 1, 2, and 3 would all increase water levels downstream by maintaining the flow within the valley corridor. Alternative Solution 2 would have the highest potential to reduce in-stream erosion. Alternative Solutions 1, 3, and 4 would all allow the existing level of erosion to continue or increase erosion potential. Alternative Solutions 1 and 2 would be easier to construct and would require fewer modifications to the surrounding area, whereas Alternative Solution 3 would have the lowest construction feasibility given the large footprint and property constraints. Alternative Solution 3 would have the highest opportunity for climate change resiliency and adaptability due to the natural channel design concepts and better connected floodplain. Overall, Alternative Solution 2 has the highest preference for technical criteria, and Alternative Solution 3 has the lowest preference. For economic criteria, Alternative Solution 3 would have the highest capital cost, mainly due to the extent of property acquisition. Alternative Solutions 1 and 2 would have similar capital costs to construct. Alternative Solutions 1 and 2 would have lower long-term operation and maintenance costs than Alternative Solution 4, the do-nothing approach. Alternative Solution 3 would have the highest long-term operation and maintenance costs due to the need for structural inspections. Alternative Solutions 1, 2, and 3 would allow for future removal of the Special Policy Area designation, which would enable development in the area as planned in the Dundas Connects Master Plan. Alternative Solutions 1, 2, and 3 would all require some adjustments or relocations to municipal servicing infrastructure, with Alternative Solution 1 requiring the fewest adjustments and Alternative Solution 3 requiring the most adjustments. Overall, Alternative Solution 1 has the highest preference for economic criteria, and Alternative Solution 3 has the lowest preference. For environmental criteria, alternative solution 2 would have the greatest opportunity to improve channel morphology through natural channel design principles, which would enhance fish or aquatic habitat. Alternative solution 2 would generate the lowest flow velocities, minimizing the risk of bank erosion. Alternative solution 1 would create higher velocities and increase erosion throughout the creek. There would be no or minimal change in the channel geometry for alternative solutions 3 and 4, leaving the current level of erosion left to continue. Alternative solutions 1, 2, and 3 would require tree removals as part of construction. Alternative solution 2 would require the highest degree of tree removal, but also would have the most opportunity to improve terrestrial habitat by providing an aquatic or terrestrial interface within the channel. Overall, alternative solution 2 has the highest preference for environmental criteria, and alternative solution 1 has the lowest preference. For social criteria, alternative solutions 1 and 2 are anticipated to be received well by planning agencies and the public. Alternative solution 3 would have a regulation resistance, as Ontario does not typically consider an FPL a permanent flood solution. Alternative solutions 1, 2, and 3 would all require some property acquisition, particularly in the area surrounding Dixie Road. Alternative solution 3 has the largest footprint, which would require extensive property acquisition. The public may oppose the extent of property acquisition required to construct an FPL. Alternative solutions 1, 2, and 3 would all have impacts to the public during construction. Alternative solution 1 would have more impacts than alternative solution 2 due to the required road raise to Dixie Road. Alternative solution number 3 would have the most impacts, as it is the largest area outside the Valley Corridor. Alternative solution 2 would have the highest potential for recreational improvements within the Valley Corridor, such as trails, connections through the bridge, and formal park areas. Alternative solution 2 would have the most potential to impact cultural heritage or archaeology due to the extensive construction area. However, the majority of the corridor has already been impacted. All alternative solutions have initial acceptance by local First Nations groups. Overall, alternative solution 2 has the highest preference for social criteria, and alternative solution 3 has the lowest preference. The evaluation outcomes show that alternative solution 2, improved channel conveyance by making room for the creek, is the most preferred solution. Further details of the evaluation assessment will be included in the forthcoming environmental study report. The proposed design for the Dixie area preferred alternative solution, which is alternative solution 2, improved conveyance by making room for the creek, would incorporate natural channel design concepts, create a wider and better connected floodplain, and replace the Dixie Road Bridge with a larger span structure. From a technical perspective, the preferred alternative solution would eliminate the spill at Queen Frederica Drive, reduce water levels upstream of Dixie Road, reduce erosion during typical flow conditions, and provide resiliency to protect against climate change through reduced water levels. From an economic perspective, this preferred alternative solution would enable future removal of the Special Policy Area designation, would be similar in cost to alternative solution 1, and lower in cost than alternative solution 3. The design would reduce the required road raise with a lower overall bridge replacement cost. There would be some impacts to municipal servicing that would require relocation, but no more than the other two design alternatives. Environmentally, the preferred alternative solution would require the most tree removals. However, it would provide the most opportunity for long-term improvements to fish habitat and terrestrial aquatic interface, and would improve sediment transport processes. Socially, the preferred alternative solution would create the most opportunity for recreational and trail improvements and would align with current City of Mississauga planning and policy initiatives. Some property acquisition would be required, and some disruption during construction at Dixie Road is anticipated, but less so than the other design alternatives. Overall, alternative solution 2 was chosen as the preferred alternative solution because it would contain the spill and provide the most improvements from a social and long-term environmental perspective when compared to the other alternative solutions, and it is similar in cost to alternative solution 1. This chart outlines the results of the alternative solutions evaluation for the Dundas area. For technical criteria, alternative solutions 1, 2, and 3 would contain the regional flood within the Valley Corridor. Alternative solution 4 would not. Alternative solutions 1, 2, and 3 show similar water level reductions upstream of Dundas Street, with alternative solution 3 showing the most reduction. Alternative solutions 1, 2, and 3 would have higher water levels downstream of the Dundas Street crossing, as the water would be contained within the valley corridor. Alternative solution 2 would have the highest water levels downstream due to the lack of floodplain conveyance. Alternative solutions 1 and 3 would have the greatest reduction in erosion potential due to the larger bridge span and floodplain conveyance improvements. Alternative solution 1 would have fewer construction requirements at the creek crossing, but would require the most road disturbance. Alternative solution 1 aligns with current municipal projects, while alternative solutions 2 and 3 conflict. Alternative solution 3 has the highest opportunity for climate change resiliency and adaptability. Overall, alternative solution 3 has the highest preference for technical criteria, and alternative solution 4 has the lowest preference. For economic criteria, alternative solution 1 would have the lowest capital costs and operations and maintenance costs due to the smaller single-span bridge size. Alternative solutions 1, 2, and 3 would all enable future removal of the special policy area designation. Alternative solution 1 would have the least impact on concurrent construction projects. Alternative solutions 1, 2, and 3 would all require some adjustments or relocations to municipal servicing infrastructure. Overall, alternative solution 1 has the highest preference for economic criteria, and alternative solution 3 has the lowest preference. For environmental criteria, alternative solution 1 would have the greatest opportunity to improve channel morphology and aquatic habitat. Alternative solutions 1, 2, and 3 would all have the potential to improve terrestrial ecology by creating connectivity through the spanned bridge, with alternative solution 3 creating the most benefit. Overall, alternative solution 1 has the highest preference for environmental criteria, and alternative solution 4 has the lowest preference. For social criteria, alternative solution 1 is most preferred from a planning perspective, as it most aligns with ongoing construction projects. Alternative solution 4 is least preferred, as it would create a new or limit the removal of the special policy area designation. Alternative solutions 1, 2, and 3 would all require some property acquisition, particularly in the area surrounding Dundas Street. Temporary easements would be a requirement for alternative solutions 1 and 3 on the West Valley Bank. Alternative solutions 1, 2, and 3 would all have impacts to the public during construction. However, the work would be coordinated with the bus rapid transit project, which is already anticipated to disrupt the public along Dundas Street. Alternative solution 1 would have more impact than alternative solutions 2 and 3 due to the higher road raise. Alternative solutions 1, 2, and 3 would all create potential for future recreational improvements within the valley corridor, such as trails and connections through the bridge. All alternative solutions would have low archaeological potential in the construction areas due to being previously disturbed. All alternative solutions have initial acceptance by First Nations. Overall, alternative solution 1 has the highest preference for social criteria, and alternative solution 4 has the lowest preference. The evaluation outcomes show that alternative solution 1, a 25-meter single-span bridge with a downstream floodplain conveyance improvements, is the most preferred option. Further details of the evaluation assessment will be included in the forthcoming environmental study report. The preferred alternative solution for the Dundas area is a 25-meter single-span bridge with downstream floodplain conveyance improvements. This solution would replace the Dundas Street Bridge with a wider single-span bridge and create a wider and better connected floodplain downstream of Dundas Street. From a technical perspective, the preferred alternative solution contains the flood within the valley corridor, with lower water levels downstream of the bridge than alternative solution 2. It is also the least challenging to implement with ongoing infrastructure initiatives on Dundas Street. Environmentally, a single-span bridge provides the most ecological and geomorphic benefits as compared to alternative solutions 2 and 3, which contain piers, and it would provide some terrestrial connectivity improvement through the bridge opening and downstream. Economically, the preferred alternative is the least expensive bridge replacement, with less operation and maintenance required than alternative solutions 2 or 3, and it would enable future removal of the special policy area designation and allow future urban development plans to move forward. Socially, the preferred alternative would require some property acquisition near Dundas Street, and it would impact adjacent property owners and businesses during construction. However, it would provide an aesthetic improvement and some future recreation opportunities. Overall, alternative solution 1 was chosen as the preferred design because it effectively conveys the regional flow, it has the most improvements from an environmental perspective, it has the lowest cost, and it has similar social impacts as alternative solutions 2 and 3. For the Dixie area, alternative solution 2, improved conveyance by making room for the creek, was selected to mitigate the spill at Queen Frederica Drive. This solution would contain the spill within the valley corridor through the Dixie area, but the additional flow would cause flooding downstream at Dundas Street. The critical conveyance issue at Dundas Street is the undersized Dundas Street Bridge. The alternative solution selected for the Dundas area is a 25-meter single-span bridge with some downstream flood conveyance improvement. Together, these two preferred alternative solutions would keep flows within the Little Etobicoke Creek Valley corridor and allow the removal of the special policy area designation. Now that the preferred alternative solutions have been selected, we will review alternative design concept considerations. Key design considerations for the Dixie area include the following. How much creek invert lowering would be required through the channel to convey the required flows? What municipal servicing infrastructure would need to be moved or protected in place? What would be the best span for the Dixie Road Bridge replacement to facilitate all the objectives of the environmental assessment? And, with that in mind, should the Dixie Road raise be minimized or eliminated completely? In terms of the channel, the city wants to optimize the valley width with as minimal property disturbance as possible, to improve trails through the area and improve access from a variety of points throughout the corridor, and to address any existing channel erosion in the study area. The first component reviewed was the creek invert elevation under Dixie Road. The first alternative investigated was to maintain the existing channel inverted under Dixie Road. This alternative was screened out as it would not be possible to achieve the hydraulic capacity needed through the bridge without lowering the channel. The second alternative investigated was the option to lower the invert of the channel by a minimum of 0.5 meters and up to 1 meter at the Dixie Road crossing. The design consideration was carried forward as it would achieve the freeboard objectives of this spill point. The second component reviewed was municipal servicing, particularly the 900mm sanitary trunk sewer that crosses under Dixie Road. The sanitary sewer is currently within 0.6 meters of the creek bed. Because the channel needs to be lowered by at least 0.5 meters to achieve the objectives, leaving the sanitary trunk sewer in place was screened out. The design consideration to lower the 900mm sanitary trunk sewer was carried forward. Some preliminary analysis was completed to show how the sewer could be lowered and connected into the existing system above Dundas Street. Another piece of municipal servicing reviewed was the 450mm sanitary sewer that crosses Little Etobicoke Creek near Jarrow Avenue. In its current condition, the 450mm sanitary sewer is visible along the creek bed, which leaves it open to environmental risk. In discussions with the Region of Peel, keeping the sewer as it is for an undetermined amount of time is not a feasible option. Leaving the sewer in place also limits the opportunity for improved floodplain and channel conveyance. Therefore, this opportunity was screened out. Two main options were reviewed to relocate the 450mm sanitary sewer. The first option would be to realign the sewer through the creek floodplain along the north side and connect it to the lowered trunk sanitary sewer at Dixie Road. This alternative was ultimately screened out as it would require additional lowering of the 900mm sanitary trunk sewer, and future maintenance and access within the floodplain would be an issue. The other option would be to lower the 450mm sanitary sewer, maintain its current alignment through Jarrow Avenue, and connect it upstream of Dundas Street. The analysis showed that this lowering would be possible, and it is the most feasible solution, as it would maintain a sewer alignment and allow access through existing easements. This option was carried forward. Another design consideration was the Dixie Road bridge span. For the alternative solutions previously evaluated, a 45-meter double-span bridge with a lower 0.5-meter invert design was used. This design concept could work hydraulically, however there are ways in which the bridge span and resulting impacts and opportunities could be optimized. Additional bridge spans were evaluated, all of which included lowering the channel by up to 1 meter at Dixie Road. The first solution evaluated was a 38-meter double-span bridge. This option is the minimum span that would meet hydraulic requirements. The second solution evaluated was a 45-meter double-span bridge, but with a 1-meter lowered channel invert. The third solution evaluated was a 50-meter triple span bridge, which is the most technically feasible triple span bridge option. A 55-meter triple span bridge was also evaluated. However, it would provide no additional hydraulic benefits and would cost more than the 50-meter triple span bridge, which led to it being screened out. The remaining 4 bridge span solutions were evaluated as alternative design concepts and are described later in this presentation. Some additional considerations were reviewed for all the Dixie area design concepts. The city wants to create trail and access improvements. The preferred alternative solution would require extensive tree and vegetation removals throughout the valley corridor. Landscaping would restore the construction disturbance, particularly in Willow Creek Park, which would contribute to long-term improvements. There is a desire to enhance the city's multi-use pathway system. This includes formalizing an existing trail downstream of Dixie Road, which connects into Fieldgate Drive. The city also wants to look at enhancing the multi-use pathway upstream to the west of Dixie Road, with additional connections through the Dixie Road Bridge opening. Additional municipal servicing infrastructure will also need to be considered. The 400mm water main at the Dixie Road Bridge currently has 1.9 meters of cover, and animal relocation would be required. A 2.4-meter feeder main access is located underneath the creek. However, it has 20 meters of cover and would not be disturbed. Exposed concrete utility boxes are present, as well as various other utilities that would require relocation. Within the study area, there are 10 stormwater outlets that discharge to Little Etobicoke Creek. These would need to be adjusted as the design progresses. Lastly, the creek width, grading, erosion control, and vegetation would need to be optimized to best fit the preferred alternative solution. During the detailed design stage, property requirements will be limited where possible, and steeper side slopes with geotechnical considerations would potentially be explored. Key design considerations for the Dundas area include channel improvements through the corridor, upstream floodproofing for an existing building, floodplain widening downstream of Dundas Street, municipal servicing infrastructure, minimizing property impacts, addressing existing erosion issues through the study area, and coordination with the bus rapid transit project. An existing building on the east side of Little Etobicoke Creek, upstream of Dundas Street, will require floodproofing due to the additional flows from the mitigated spill at Queen Frederica Drive. 3 options to mitigate the flooding were reviewed. The first option is to raise the existing berm to prevent overtopping. This option could work to contain the flow within the valley corridor and protect the property from flooding. Another option is to widen the channel immediately upstream of Dundas Street East. This option would not reduce the water level sufficiently to prevent property flooding. Similarly, the option of moving the existing berm back 20 meters and widening the channel was reviewed. However, this option would also not reduce the water level sufficiently to prevent property flooding. Therefore, the only option carried forward is to raise the existing berm on the property. The floodplain widening downstream of Dundas Street along the west bank was reevaluated during the alternative design concept process. Although the widening did show some hydraulic improvements as part of the evaluation, it may be limited hydraulically due to the confined valley system setting upstream and downstream. A more detailed evaluation of this alternative design concept was completed to determine more holistic benefits and potential drawbacks to implementing. Additional considerations for the Dundas area included overall channel improvements to improve habitat connectivity and geomorphology through the larger bridge structure and tie-ins up and downstream. The works would also address existing erosion site setup identified along the bed and banks as part of the technical studies work. The design concept would limit property encroachment and work within the confined valley system that exists up and downstream of Dundas. Servicing infrastructure was also identified within the study area. This includes a sanitary siphon, which will require relocation along Dundas Street due to the bridge works. Ongoing coordination will be required for the planned construction of a 200mm diameter water main along Dundas Street. Lastly, there are 6 stormwater outfalls that discharge into Little Etobicoke Creek, which will need to be adjusted as the design progresses. We will now review the evaluation of the alternative design concepts for the Dixie Road Bridge. As described previously, there are 4 alternative design concepts for the Dixie Road Bridge replacement. These include 38, 44, and 50-meter span bridge alternatives combined with 0.5 to 1 meter of channel lowering through the crossing. All 4 bridge alternatives provide the required 0.5 meter of freeboard during the regional event at the spill location upstream of Dixie Road at Queen Frederica Drive. The 3 alternatives with the 1 meter channel lowering also provide 0.5 meters of freeboard at the Dixie Road Bridge crossing. The alternative solution evaluated during Phase 2 of the environmental assessment would require a road raise, whereas the 3 other design concepts would maintain the current road elevation. All bridge alternatives have similar costs, with the lowest cost being the 38-meter double-span bridge and the highest cost being the 45-meter double-span bridge with 0.5 meter invert lowering, which is more costly due to the required road raise. The criteria used to evaluate the alternative design concepts was based on the criteria used to evaluate the alternative solutions, with some minor adjustments made to better compare and contrast the proposed concepts. This criteria will be refined based on comments received from this PIC. The preferred alternative design concept will be advanced through the environmental assessment and into the 30% design stage. Jumping into the preliminary design concept evaluation, it should be noted that all 4 design concepts meet the objective of the environmental assessment, which is to contain the flow within the valley corridor. Alternative Design Concept 1 would create higher water levels upstream of Dixie Road and at the spill location, giving it the lowest opportunity for climate change resiliency and adaptability. Alternative Design Concepts 2 and 4 would create similar reductions in water levels upstream, with Alternative Design Concept 4 being the most resilient. Alternative Design Concept 1 would be the most complex to construct due to the road raise required. There could also be more challenges with constructing Alternative Design Concept 4 due to the larger span and channel alignment. In terms of economics, the capital costs associated with each bridge replacement were shown on the previous slide. Operation and maintenance costs would be similar, but slightly higher for Alternative Design Concepts 1, 2, and 3 due to the single pier, which could result in increased costs due to ice or debris jams during high flows. The alternative design concepts will impact municipal servicing in the area and require the relocation of the 900 millimeter trunk sanitary sewer, the 400 millimeter water main, as well as various utilities. Additional adjustments may be required for the alternative design concept 4 due to the larger span. All the alternative design concepts provide the opportunity to improve the aquatic and terrestrial habitat. Alternative design concepts 2 and 3 provide more opportunity due to the lower channel than alternative design concept 1. Alternative design concept 4 provides the most opportunity for connectivity as well as improved channel alignment, which can be centered through the double piers. From a social perspective, temporary easements and property acquisition would be required on the north and south banks for all design concepts. There is potential for more property acquisition to be required for the 50-meter span bridge to align the creek in the valley corridor. Design Concept 1 will cause the most disruption to the public due to the required road raise. With respect to trail connections, Alternative Design Concept 4 has the most potential to accommodate the requested trail connections on either side of the channel, whereas the 3 other design concepts would be constrained to one side of the pier. The preliminary evaluation of the alternative design concepts is summarized visually in the table. For technical criteria, Alternative Design Concept 4 is the most preferred, followed by Alternative Design Concept 2. For economic criteria, Alternative Design Concept 3 is the most preferred, followed by Alternative Design Concept 2. For environmental criteria, Alternative Design Concept 4 is the most preferred, followed by Alternative Design Concept 2. For social criteria, Alternative Design Concepts 2 and 3 have equal preference, followed by Alternative Design Concept 4. As shown in the scoring, Alternative Design Concepts 2, 3, and 4 have similar overall evaluation outcomes, with Alternative Design Concept 4 being slightly preferred over the others. The preliminary preferred design concept will be confirmed after receiving and considering input from the public and stakeholders. The evaluation summary for the preliminary preferred design concept is outlined on this slide. Without going into all the details, as they have been explained through the previous slides, ultimately the 50-meter triple span bridge with lowered 1-meter invert is preferred because it provides the most improvements from a technical and environmental perspective, with similar social benefits to Alternative Design Concepts 2 and 3. It would cost more than alternative design concepts 2 and 3, but would be the most resilient and adaptable solution, providing flexibility to vary the channel invert during detailed design. We will now review the alternative design concepts for the Dundas area. 2 alternative design concepts were evaluated for the Dundas area. The first was maximizing the floodplain area downstream of Dundas Street. The maximized floodplain is located on city-owned land along the west side of the creek. The proposed design would provide 25 meters of floodplain adjacent to the 1-meter channel. The design would include channel works that address erosion sites on both west and east sides of the channel. It should be noted that regardless of this alternative being selected, channel works are still required upstream of the Dundas Street Bridge, as well as through the bridge area to facilitate a stable transition. The comparison alternative would be completing no floodplain improvements downstream, also known as the do-nothing scenario, for the floodplain conveyance. The existing floodplain conditions would remain downstream of Dundas Street. Channel works would still be required upstream of the Dundas Street Bridge, as well as through the bridge area to facilitate a stable transition. Downstream, the existing erosion sites are not addressed, and restoration would need to be completed as isolated works. We will now go through the alternative design concept evaluation for the Dundas area. Looking at the technical criteria, there would be minor improvements to water levels upstream of Dundas Street with the floodplain widening. There could be more improvement to the water levels downstream of Dundas Street. However, this would only extend for approximately 200 meters where the floodplain works would take place. There would be improvement to erosion potential, specifically in the area of floodplain widening and channel restoration. These channel and floodplain modifications would provide additional resiliency against future climate change. Some challenges with implementing alternative design concept 1 include the need to have access granted through an easement and the challenging steep valley grades. Alternative design concept 1 has the highest capital costs, but fewer future operation and maintenance costs, as erosion conditions through the valley would be improved over the long term. Implementing alternative design concept number 1 would also reduce the need to complete the required erosion works in isolated projects. Alternative design concept 2 would result in higher long-term operation and maintenance costs, as the erosive conditions would be left to continue. Alternative design concept 1 would require adjustments to an existing stormwater outfall. Alternative design concept 1 would create improved geomorphic, terrestrial, and aquatic conditions downstream of Dundas Street. Socially, criteria shows that both design concepts are anticipated to have high acceptance by planning and policy agencies. Alternative design concept 1 would require a temporary easement during construction, but no property acquisitions. There could be some disruption to adjacent landowners, however this is expected to be minimal compared to the planned bus rapid transit project construction. Alternative design concept 1 would improve aesthetics and leave some potential for trail access and connections. Preliminary evaluation of the alternative design concepts is summarized visually in the table. For the technical criteria, alternative design concept 1 is preferred over alternative design concept 2. For economic criteria, alternative design concept 2 is preferred over alternative design concept 1. For environmental criteria, alternative design concept 1 is preferred over alternative design concept 2. For social criteria, alternative design concept 2 is preferred over alternative design concept 1. As shown in the scoring, the alternative design concepts have similar overall evaluation outcomes, with alternative design concept 1 preferred overall. The preliminary preferred design concept will be confirmed after receiving and considering input from the public and stakeholders. The evaluation summary for the preliminary preferred design concept is outlined on this slide. Without going into all the details, as they have been explained through previous slides, ultimately the maximized floodplain area downstream of Dundas Street is preferred because it reduces water levels downstream of the Dundas Street Bridge and improves the environment, including localized erosion issues. Let's review the overall preliminary preferred design concepts and the next steps of the environmental assessment. The overall preliminary preferred design concept for the Dixie area is shown in this figure. Floodplain restoration and channel conveyance improvements would happen throughout the entire corridor from upstream of Dixie Road to the downstream bend. The channel would need to be lowered between 0.5 meters and 1 meter, particularly in the area of Dixie Road. The channel lowering would require the lowering of the 900 millimeter trunk sanitary sewer under Dixie Road, as well as the sanitary sewer crossing near Jarrow Avenue. The Dixie Road Bridge would be replaced with a new 50-meter triple-span bridge. Valley widths through the corridor will be optimized to minimize property takings where possible. Trail connections are proposed through the valley and underneath the new Dixie Road Bridge. The construction works would require tree removal and regrading, followed by a period of construction and planting, and then on to restoration. The overall preliminary preferred design concept for the Dundas area is shown in this figure. Floodplain restoration and channel improvement would happen from upstream of Dundas Street to approximately 300 meters downstream. The Dundas Street Bridge would be replaced with a 25-meter single-span bridge. The sanitary siphon would require relocation due to the bridge replacement. A design concept has been developed that would raise the berm on the east property upstream of Dundas Street for floodproofing. There are several benefits of the preliminary preferred design concept, which meets all the objectives of the environmental assessment. The preferred design concept would address riverine and urban flooding issues and enable removal of the special policy area designation. The design would support ongoing City of Mississauga infrastructure projects. It would provide resiliency and adaptability to climate change and protect the surrounding community for the future. Making room for the creek creates a more naturalized channel and valley corridor, improving the aquatic and terrestrial interface. Where possible, the design would minimize impacts to private properties, and the effects would be limited to areas directly adjacent to the valley corridor. This design is a feasible infrastructure solution that would enable future growth and development for the City of Mississauga and region of Peel. The next steps in the environmental assessment process include integrating input from stakeholders and reviewing the alternative design concepts to select the preferred concept. The project team will then work toward completing the environmental study report, which is planned to be issued this summer for a 30-day review period. The preliminary and detailed design will be completed throughout the remainder of 2023 and is planned to continue into 2025. Construction is anticipated to start in 2025 with the bus rapid transit and Dundas Street Bridge replacement. Work will generally be completed from downstream to upstream to properly accommodate the increased flows once flooding is contained within the channel. As a reminder, please go to the City of Mississauga's website, which is at www.mississauga.ca/flooding, and sign up to be on the project mailing list, and please fill out a comment form, as your input is very valuable. We will be receiving input until June 23, 2023, and gathering your input toward the next phase of the work to be completed. Thank you very much, and we look forward to hearing from you.